Okay. In the first week, we have talked about the system, input-output, and the other definition related to the system dynamics. Okay? And so, firstly, we must define the system. What's the system? Can you tell me?
System is a group of inputs and outputs operating to do a certain function.
Please, could you close the windows? Yes, at that time. Okay. Too much noise. Yes, that too. What is a system? In engineering perspective, a system, a combination of something. Combination of elements or parts intended to do what? To act a what? A purpose. Act or accomplish a purpose or task. Okay? If we have this definition, and then we can say that everything can be said to the what? To the system. Okay? We have elements and parts, and so these elements combining together, and then we can create some task or performing the task. Okay? And so if we have this information, and then the elements and the combination must be given in here. Okay? And so these elements create what? This combination. And so this combination also creates the elements in here. And so if we want to design a system, and so either we can focus on the elements or its combination. Okay? Either elements is important or the combination of them is important. Okay? And so if we have this definition, and then we can complete the what? The task in here. Okay? Task means the purpose. Okay? Without purpose, we don't have any system to be used in that system, right? And so we must use this definition to create what? The system dynamics in an engineering perspective, guys. Okay? And so this system must be connected to each other, right? Otherwise, we cannot say that this is a system, right? This is an element, like the spring or the mass, okay? The mass cannot be considered as a system because it's an only unique element to define to what the physical laws of the universe, okay? And so, if we combine these two things, M or the electricity or the something like that, to create or accomplish a purpose, and so we must combine them and we connect them, link them to the other things, but in a way of the what? Using the math. Okay? And so how can we define an example of these things? The example can be created with what? For example, we have the bicycle in here, just like this one. Okay? This is a bicycle. And so in order to run this bicycle, we can add to what? The motor, right? And so this bicycle is a system or not? System. But why? Why? Please be loud. Please be loud. Okay? Yes. Okay. So could you close this window? Okay. I'm sorry, guys, about the condition of this, but I cannot hear you right now. So tell me again. Yes. Yes. We have the motor and the bicycle. Bicycle is a mechanical part, right? And so we have two parts in here, right? Two parts. And so one of them is the what? The bicycle, right? And so the other thing is a motor, right? And so these two are the elements of these courses, okay? And so what's our task in here? Task is to drive bicycle without falling, okay? Our task is that. This is our purpose. Okay? And so if we have these two conditions, and so we can say that it's a bicycle system. But the bicycle system contains to what? The two components, right? It's a mechanical part and the electrical part, right? And so if we have this information, and then as an engineer, we can define to what this as a parameter to model these things, right? Because anyone can do that. The bicycle has a motor and bicycle, but if we are mechatronic engineering, and then we can define some subsystem or the mechatronical parameters to define this system, okay? And so the whole operation can be shown as the what? We have a motor in here, okay? And so this motor produces something in here, and then we have the bicycle in here, okay? And so this motor considered as a subsystem, okay? One. And so the other thing is the subsystem 2, okay? And so what is produced from this bicycle in here? Motion or position, right? This is the position. What do we need to produce or to feed this bicycle to produce the position? What's the input of these values? What? Force, right? And so in order to create the force, which parameter should be implemented or applied to the motor? Yes, electricity, current, or voltage, right? And so this is a one system, okay? But in that system we have the electrical part and also we have the mechanical part. But our purpose is that the position must be produced from this system based on the what? The combination of these two things, okay? And so if we split every part or the elements of this system, total system, into the what? To the electric motor or the bicycle, and then we can solve it easily by using the system dynamics methods or in general the mathematical methods, okay? So we need to define to what the general name for the what? For the current, force, or the position, which we call it to the what? To input and output, okay? So in the system 1 we have this information. If we apply the current and motor run, right? If we apply the current and the motor run, this happen. And so in the system 2, if the motor runs and bicycle moves, right? This is simple sentences about the what? About the condition of the system 1 and 2, okay? But what is the input of the system 1 in here? Maybe we can ask this, what's your name? What's your name? Yes? Jada. Jada. What is the input value for the system 1 in here? What's the input? Yes, that's simple, right? This is the input. What is the output of this system? What's your name? No, no, no. No, no, no. That's the Ro? Rauda. Rauda. Okay, it's the runs means that in here. No, 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 no. It's the how we can call the what in general definition in here. This is the what if this is the input and this is the output, right? And so for the system 2, what's the meaning of the runs in here? Yes? And so moves the output, okay? And so we have the many definition about this system. If we split the one main system into the subsystem, and so we can define the what the input output, and so we can link the each other to these parts, and so we can solve it by using the system dynamics methods, okay? But in general, we have the basic condition in here, just like this one. If we have the any system in here, like this one, this is the system. And so we have the cause in here. At the left hand side of this system, there must be always a cause, okay? And so this cause is applied to this system to produce to what? What? No, not purpose. Effect. Cause and effect, right? It's the determination of the determinism, the basis of the determinisms, okay? Cause and effect, right? And so this cause can be considered as the water current, or speaking, or moving, or something like that. And the effect of the water listening to the people, the effect, okay? Teaching the what? System dynamics, maybe. Or the torque values, okay? Okay. Okay. And so, in summary, this is the due to. This is the produced one. Okay? General. We shall generate the produced results to condition the system based on the what? The cause. Okay? But as an engineer, we should define some more technical details in here for the bicycle. Okay? We can use some identifier parameters or the symbols, right? And so, in general, this system as defined, the current is applied to the what? The system 1, and this generates to the what? The torque or force value. And so this torque or force value is given to the what? The system 2, and this generates to what? The x or v, velocity. Okay? But in the engineering perspective, we must utilize to what? Some basic rules to define the system boundaries or the restriction or the limitations of these systems. And so, which rules can be used to define these systems? In general, the laws of nature. In mathematical form, for example, can you say me any rule or the law of the nature? For example, what's your name? Maria. Okay. Gravity, but this is not the law of the nature. Okay? Maybe. Which guys found the gravity? No. For example, the Kirchhoff law. Okay? For example, the Newton's law. Right? The gravity comes from the what? The Newton's law. Right? Otherwise, we cannot define the gravity, because the gravity produces the what? The force based on the what? The some parameters, which we call it the mass, right? And so, the laws of the nature can be described with the what? The Kirchhoff law, or conservation of the mass, or the what? Newton's law, right? This is the basic rules to define this system. And so, if we have these parameters, and then we can utilize the math to describe it, right? We can use this mathematical equation to what? To define these systems, okay? And so, if we have nature laws, and so, which one of them is the what? The conservation of mass. What's the meaning of this? What's your name? No, you. At the behind end, yes. What's your name? Yusuf. Or Yusuf? Yusuf, yes. Okay. What's the meaning of the conservation of mass?
The mass that enters is the same as the mass that exits. Entering masses equals the...
Yes. Or in another term, another manner, we cannot create the mass or destroy it, because we are limited by the what? Nature or God, right? Okay. This conservation of mass is a boundary of our definition. We must obey this rule to drive any mathematical equation based on the physics, okay? We should use that. Otherwise, they are nonsense, okay? Yes? No, because there are two lots coming from inside, okay? But maybe one window can be opened, okay? Okay. So, this conservation of mass preserves every energy in the universe. But we have the effect and cause by physics, because we must obey the what? The time. Time is linear and goes to the what? To the forward, okay? Which we call it the dynamic, right? And so if I move my hand, and so this is the dynamic, because the mass is what? Is going to left and right, right? And so I have a constant mass in here, but this mass rotate or translate to the what? The left and right, or counterclockwise or clockwise, right? And so if we have this definition in here, and so if we have also a time, and then we can create a system, but based on these rules in here, okay? And so we can give the cause in here. For example, for my hand, and so I order my muscle to produce the force, right? Coming from the brain. And so my hand going to left or the right, right? And so this cause affects our system to what? To move left or right. And so must gives the effect in here, and then how we can utilize this rule in here. I have a constant mass in here, right? My hand, for example, this is 1 kilogram, okay? And so this must be preserved in this system. And so these boundaries in here must be protected or limited from the what? From the conservation of mass. And so maybe we can write the d dt, dE, dV equals force, okay? Coming from the what? The Euler-Lagrange equation. You may not know these things, but in the next lesson we will talk about it, okay? And so if we have this information, and so we can preserve the energy. This creates a dynamic because we have taken the what? The derivative of the what? The time parameter in here. But preservation coming from the what? Momentum, right? mv, or the energy 1 divided by 2 mv over 2, right? This is the kinetic energy, right? But this energy can be changed with the limitation of the what? What? This mass rule, okay? This is our limit in the boundary condition. For example, if you want to solve any electrical circuit, for example, we have the 1 resistor and 1 capacitor, and so what do? And so you can define the currents for the resistance and the capacitance, and so you equalize these two currents in here, just like this one, CR, right? And so I1 and I2 from the basis of the electrical currents, and so we can say that the I1 must be equal to I2, right? This simple information. But it is the basis of the Kirchhoff law, or it is the basis of the what? The conservation of the mass rule. Otherwise, we cannot write this equality in here, I1 and I2. This definition is coming from the what? The conservation of the energy. In electricity, we call it to the what? The Kirchhoff law. In fluid or hydraulics or the pneumatic systems, we can say the conservation of the mass, okay? And so if we have a system, there should be always to the what? The conservation of the something. And after that, if we have the effects and the cause, and so we can create the dynamic, which is defined in the math with the what? With this d divided by dt, or the derivative operator, okay? This is the general definition of the what? Our nature laws applied on the math or in mechatronic engineering systems, okay? And so just remember that this the x, for example, just remember the dynamic lesson. We have the mass, and so F, and so we can define the x. What's the equation of this function? How we can define the dynamic derivation or the dynamic equation of these forms? Yes. F must be to what? Proportional with the m and acceleration, or the second derivative of the what? The position values, okay? And so if we have this information just like this one in the 3 dimensions, we can say that this m at the direction of this arrow with the what? The velocity v, okay? And so just remember the Newton's law. If the mass continues to move and continue, right? until to what? Huh? Yes, zero acceleration. But why? Because we don't have any cause to what? To increase the velocity or decrease the velocity, right? This is the what? One of the Newton's law in the universe, okay? And so, if we have this information, and then we can say that we have only the momentum term in here, m dot v, right? Because if we have the v, and so we have the energy proportional with the what? With the m values, the mass value, right? And so, if we have this momentum, if we take the derivative of this term, dp, momentum divided by dt, what is, or this value, which value is equals to this one in here? If we have any change in the universe based on the momentum, is defined with the what? No, force value. If we have any change in the momentum or the energy, and so there should be an effect. This is the definition of the force. The force definition does not come here, okay? The change in the momentum in time defines to what? The force. And so this force is taken with these values in here, just like this one, dp dt, and so m v dot, and so which we call it to the what? The acceleration of these terms. And so firstly, we define these terms. The momentum change in time creates the force value, the effect, and so this effect is applied on the m dot x dot dot, and so this is coming from generations, okay? And so we can create the energy forming here by using these definitions, because in this definition dp must be equal to f dt, right? This is the effect. We don't know the values of these terms, but if we have any change in momentum in time, and so this could be considered as the what? The force. This is the definition of the force. Definition of the force is not m times x dot dot, okay? Definition of the force, the rate of the change of the momentum in time, okay? And so we can create this form in here, just like this one, and so also dp m dv can be right in here, okay? Because if we have this definition, and so we can use this term in order to what? In order to create these forms. Just taking to what? The f is replaced with this one, and so dv is coming from in here. And then if we have this information, this is also equals to what? The f dt. Can anyone remember this definition? F times dt is equals to the what? M times v, right? This is the basic rule for the what? For the impact analysis in the dynamics, okay? And so if we have this information, or the velocity is changed or not, and so the energy must be changed, and then the energy can be defined with what? The m v. This is the what? It's the momentum, but momentum change in time gives us the what? The kinetic energy in here with these definitions, okay? This is why we use the m dot v in the what? In the energy formulation, okay? Because we cannot create this energy or not, and so we cannot use the dt values in here in order to calculate this energy. Because we know that if the velocity is increased, and so our energy is changed. But if the time is changed, we cannot say that the energy is changed. We cannot say that. But if we have any velocity change, and so we can say that the energy is changed. Okay? But in the time form, we cannot say that. The energy is always constant or preserved from this energy. And so this is the basic proof of the kinetic energy. Okay? So these are the system definition and the boundary limits or the restriction of the R parameters. But we can say that on the 3 we can give some other definition in here. Okay? And so we have in mechatronic engineering, or studying the mechatronics, we have the static and dynamic elements. And so what is the meaning of the static? Huh? Tell me.
No motion stays in space.
Huh?
Doesn't move in space.
No. No, stop. This is not the definition. The statics, the first, if you define anything in mechatronic engineering, we must focus on or look at what it's time dependent or not. Okay? And so the statics is not time dependent. Right? Because in the static lesson or the course, just remember that every material has a what? Constant velocity, which is equals to what? 0, right? Everything is stopped. Okay? And so we don't have any movement. But in the dynamics, we have the mass moving to the what? The right, left, up, down, right? And so what is the meaning of the statics? Statics can be defined in here just like this one. In mathematical formations, the present value of output depends on present value of input, right? Because we have the definition of the input, we have the definition of the output, right? And so the statics is a model or the system, right? Because this is the course of system dynamics, okay? And so we must define the statics in terms of what? System dynamics components, okay? And so what is the present value in here? For example, just remember that F is equals to the K times X. K, what's the K in here? Constant. And so it is a spring factor, right? And so is it statics or not? Is it static or not? Huh? Not. Why? Please be loud. Okay?
There is no acceleration, x is 0.
Yes, and so which is this is static or the dynamic? Static. Why? Because huh?
No change in acceleration.
No change in acceleration or no change in x or otherwise. Just see that. If we have the k in here just like the 1, okay? And so if I put the 5 meter in here, and so what's the force value? 5 or 100. And so what's the force value? 100. And so which means that if we have the x value, automatically we can calculate the f value in here. This is called the what? Static element. But we have also a dynamic element. And so from this definition, the present value of output depends on both with what? Huh? Both? No. Yes, for example, the dynamic components depends on the present value of input.
Acceleration.
No, not acceleration. The present value of the output should be depending on both of the present value and also yes. Who said that? What's your name? Bilal. Nice to meet you. Past. Okay? Answer. How can we define the dynamic equation in here? Just tell me. For example, what's your name? What's your name? No. You. Izzet. Izzet. Just tell me any equation that's defined dynamic. Car accelerating. But just tell me. Tell me. I can write.
Equation.
Yes. F equal
200 x squared equation of minus 3x plus 1.
huh?
3x
Phi 3
x minus 1.
minus 1. This is dynamic or not? Why?
If we have x, we can complete it.
Huh?
If we have x, we can complete that direction.
Yes. If we have the x and complete it totally, we can calculate the f. For example, I can tell that IC is equals to the what? The C dVc divided by dt. If we have the voltage value in here, the present value, we cannot calculate directly IC. Why?
It's changing the time.
Yes, but why? Yes, because we don't know anything about the past value because we have the derivative operator in here, right? And so, if we don't have any past value, we cannot say the present value of the what IC, which is the derivative, which is the time dependency, right? Okay? We have two special operators in math for this time dependency. One of them is the derivative. The other one is that. The other one, tell me. Other one? Huh? Other one? Other one? Yes. Konuşmaya o kadar korkuyorsunuz ki anlatamam yani. Hani o kadar basit şeyler ki aslında anlattığım şeyler. Integral. Okay? And so, if we have any derivative or the integral operator, we can say that this system is, what's your name? Lady? Yes. What's your name? Beza. This is time dependent and this is the dynamic system. Okay. So, if we have this information and so this input and also we have the output in here, right? And so we have the system. For example, if we have a system just like this one, we can write this. What is the input value for this equation? This is a system or not? System. What's your name? Tell me again. Ece. Hacer. Hacer. Why? Why this is a system? Why? Yes. We have a cause and we can generate to what? Another term, right? If we apply the force value, and so we can have the what? The x position. We convert the what? The force to something like that, right? X. If we apply the what? The f, and also if we have the f, the force value, is this a system or not? The input and the output are the same units. And so, then, can we call it to a system or not? System. Why?
It changed by factor of 1, right? We can multiply.
Right, just like, yes, just like this one, okay? For example, the op-amp circuits, right? We can increase the voltage value, right? For example, if we have input voltage 1, and so we can increase the watt with the gain of the 5. But we have the watt, the resistors, op-amp, and so we can create the dynamics of these terms, right? And then this is F, this is X. And so what is the function or the equation of this system? What should I write in that box? F over K. No.
X2 minus X1.
No. 1 over? Yes. Bilal. You're perfect. That's so simple, right? And so this is the input, this is the output, and so we can convert anything about this one. But we have the another parameters in here, okay? And so this system must be defined from the what? The boundary conditions. What is the boundary condition? Yes. Who said that? What's your name? Huh? Mentalla. Mentalla. Okay. Observation of mass. And so we can say that this K preserves the energy or not. Is that true? This should be. Huh?
It does.
It does. Yes. Because otherwise we cannot write this 1 divided by K. It should be mandated by the what? By the conservation of the something. We don't know about the something. Okay? And so, if we are using this formulation, 1 divided by K, and so this boundary condition can be converted into the what? The mathematical equations. Just like this one. Right? Equations. But if this is a dynamic system, we have one more important parameter that we must obey all the time, which is, yes, time. Okay? If we have a time, and so we have a dynamicity. If we don't have the time, and so we don't have anything. Okay? And so